B. So they're asking us to solve the inequality 2x plus 4 less than 8 and 5 minus x less than 9. All right. Again, what we do is solve each inequality individually. And that's going to be negative. Let's solve the first one individually. That's going to be 2x less than 4. And then divide both sides by 2 to get the x by itself. Right, that's going to cancel the 2's, and that's going to leave us with x less than 2. All right, so that's our first inequality solved. Let me draw a line to split this from, or to divide the separated from the second inequality, the solution to the second inequality. All right. Well, what do we have? 5 minus x less than 9. Again, some of you, for some reason, were moving the x's to the right-hand side of the equation because for some reason, maybe you were afraid of working with negatives on the left-hand side or something. So again, regardless of what you have, make sure to have all the variables on the left-hand side and the constant values on the right-hand side, because the way we read inequalities, we always read them a letter, inequality symbol, and then whatever value, whatever number. All right? So in this case, let's see. Let's solve this inequality. Let's subtract 5 from both sides. And that's going to leave us with negative x less than 4. All right? And well, here we need to divide both sides by negative 1. But what happens to an inequality when we divide both sides or multiply by negative? It flips, right? The inequality sign flips. So x becomes greater than negative 4. And these are the two solution sets that we are going to plot separately, and then we're going to overlap them to find the intersections of them. All right, let's see what about it. So again, this will be our set A, this will be our set B. And here we're going to look at the intersection between A and B. All right, so that's going to be 0, 0, just for the reference and just to have a number sense in here. All right, let's plot these two inequalities, this pair of inequalities. So let's see. Let's see. So let's shade this inequality. So for letter A, let me plot. Let me go to positive 2. And then from there, we are going to shade to the right, because this inequality symbol means less than, and all the numbers that are less than 2 are to the left of 2. Or that's one way to interpret inequality. The other way is to look at the inequality symbol. You can think of it as an arrow, in this case pointing towards the left. All right? And I'm going to use different colors to shade this. I'm going to use blue for set A. For set B, okay, let's see that. I'm going to go to negative 4, 1, 2, 3, and 4. And also parentheses, because for both we have just the less than or greater than. There's no equal part. So we just use the parentheses. And then we go, oh, actually different color. And I think I used this one, right? Yes. And then from here, now we're going to overlap them. That is, again, make a sandwich with them. Think of putting them on top of one another, and we're going to find we're going to see the intersection between the two. All right. So that is positive 2 rather, and negative 4. All right. That's 1, 2, 3, 4 right here. All right. So towards the left, the shading in blue. No, not this blue, actually. This blue. No, not that one. this blue, and then this red towards the right. And again, we're looking for the intersection in this case. And the intersection looks like this, the overlap. And that is going to go between -4 and 2. And that's going to be our final answer. So from the visual here where the two colors overlap, that's going to be our solution using interval notation. And from here, okay, solution set. That's going to be -4, 2. But again, we're also expected to write this result using set builder notation, not just the interval notation. So that's going to be x such that x is between -4 and 2. However, we just put the less than without the equal because again we have parentheses. We don't have any brackets in any of the cases. All right. First of all, notice here for each individual inequality, we have parentheses. That means we need to use the distributive property first before being able to solve the inequality. Or actually, you can divide both sides by 2 because it turns out that 12 is divisible by 6. So either way, you can do it. But well, I already did the distribution. So 6x minus 2 minus 12 rather, less than 12. And then how about we add a 12 to both sides, and that's a 6x less than 24, and then divide both sides by 6 to get x less than 4. All right, so that's the result for our first individual inequality. Let's look at the second one, and well, this time I'm going to divide both sides by 4 because even distributing the 4 or dividing both sides, that can go evenly with the 12, and that's going to be x plus 3 greater than, what's that, 3, and then subtract both sides, the 3, to get the x by itself, and that's going to leave us with x greater than 0. That's because in this case, notice how all the 3's go away on both sides, leaving us with 0 on the right hand side. All right, now here is the thing. Now that we have these two sets, let's label this as our set A and this as our set B. All right, and let's draw them and plot them in the number line, and then find the intersection of them. All right, so that's A, that's B, and that's A intersection B. Why is it the intersection? Because we have an and as opposed to an or, which would have been the union of the two sets. All right, now let's see. Again, my advice, write a 0 in the very middle just for reference, just to have some sort of a sense, a number sense in this case. Well, let's go to +4. That's going to be 1, 2, 3, 4, in parentheses, and then I'm going to shade this towards the left, because again the inequality symbol less than indicates all the numbers towards the left, and then as opposed to, what's that, 0, and for 0, and that's let me shade the other way. And now let's put the two sets together. So putting the two sets together, that's going to be all the numbers that are going to be between. So that's 1, 2, 3, and 4. All right. And everything towards the left in blue, everything towards the right of 0 with red or pink. And again, we're looking for the intersection, also known as the overlap. And while the overlapping here will be between 0 and 4. All right? So solution set. Using interval notation, well, this one from the picture is really easy to get because we already get the grouping symbols. In this case, parentheses for both. All right. Again, we use parentheses for both because we are missing the equal here. Had we had those equals below the inequality signs, we would have used brackets otherwise. All right. But that's not the case. Now, so that's going to go between 0 and 4. And then, so that's x such that x goes between 0 and 4. Again, to go between interval notation to set builder notation, or rather, to go to the inequality symbol, just put the x in the middle and write the inequality symbols related to the corresponding grouping symbols. Less than or equal if it's bracket, or less than if it's just parentheses. In this case, just parentheses. All right. And well, that's about and inequalities, what we usually call the and, the and type 1. All right. Now let's look at another kind of inequality involving the word and. We usually call it the inequality type, the intersection type 2. All right. Well, so in this case, yes, Scott.
On the number we were just on C,
Sure. Let me go back.
I just had a question.
Mm-hmm.
When do we use on the solution underneath the solution, the first solution set for x? When do we use? What's the difference between writing it out like that and then the x such as x?
Yes.
E and the double R?
Mm-hmm. Oh, that's when you have all real numbers. The x. So here it's only the set of numbers that are between 0 and 4, excluding the endpoints 0 and 4. But if you were to describe all real numbers using intervals, you go negative infinity to positive infinity, or the set builder notation, x belongs to the set of all real numbers. All right. But that's a whole different solution. That's another kind of set. That's if the domain were all real numbers. In this case, the domain we're looking at is only the intersection between the two. For example, and I think we did one like this last time for the OR inequality. I think we did one in which everything was shaded. We did a union of the two sets, and in that case we were looking for the elements that are in one set, the other, or both, which pretty much spans the whole thing, right? And that's where we get. Actually, let me scroll up to just to show you. Yes, this one right here, right? It was letter C, but in this case for the one. Well, it's actually the same set of inequalities, but all I did is change the or for an and. All right?
That's right.
Mm-hmm. Sure. Did that help?
Yeah.
Yeah, sure. No, that's fine. That's fine. All right, let's see. Let's move on to the third kind of inequality. Well, these inequalities are going to look like this, like having three sides. Well, you already have an idea of how these inequalities look like, but where those inequalities look like only the variable x and numbers on the endpoints. Well, what we're going to do this time, we're going to have an algebraic expression here an algebraic expression in order to, then our goal is to not to solve for, well, yes, we're technically solving for x, but this time our goal is to leave the x by itself in the middle. That is, make it look like something like this, you know? And well, for instance, let's focus on the 2x plus 6. Our goal is to get rid of the 6 and get rid of the 2. So we need to do two operations. However, back when we solved inequalities with only two sides, we did operations on both sides of the inequality or an equation. Here, we're going to do the operations on the three sides. So we're going to do the following. Negative 6, subtract 6 on the three sides, not on both sides, on the three sides. And that's going to lead us to 2x less than 14 minus 6, that's 8, and greater than or equal 0 minus 6, which is negative 6. And then our goal is to get the x by itself, which we're just one step away to get that done. So all we do here is divide both sides by 2. Right, divide both sides by 2, and that actually cancels the 2's right here, and just divide to get x. Negative 6 over 2, that's negative 3. 8 over 2, that equals to 4. All right, and that's the kind of inequality that you are familiar with already. And now express this using interval notation and set builder notation. So this inequality we had, this statement we had at the very end, it's pretty much ready to just be copied and pasted into curly braces for the set builder notation. So that means x such that, and just copy and paste. Negative 3 less than or equal x less than, actually just less than here, 4. And using interval notation, just write down the endpoints, negative 3 and 4, brackets for negative 3, parentheses for 4, and the reason to that is that we have the equal part, and here we don't have the equal part. Yes?
Is 0 like neutral, like it's not positive or negative?
Yes, it's neutral, that's correct. That is correct.
So we won't have to switch it.
No, not in this case. Well, actually, it's addition in the situation in which we switch inequality symbols. That's when we divide or multiply by negative numbers. So subtracting, or rather adding negative number, that doesn't change. That doesn't change the inequality symbol. Only the multiplication and the division.
Okay.
Right? Sure, no worries. Let's do another one here. All right, so this time we also have a three-sided inequality. It's also known as a compound inequality because in the end that's going to give us an interval of values. Well, but the thing here now, we have this quotient between the 4x minus 3 and 3. So we need to get rid of 3, which is dividing, so we need to do the opposite of the division. What do we need to do in this case? Multiply, right? So multiply the three sides by 3, all right? That's going to be negative 3 times 4, which is negative 12. Here the 3's are going to get canceled. That's less than or equal 4x minus 3. And that less than 3 times 3, which is 9, all right? And now let's see. Let's go ahead and add the 3 to the three sides, rather. And cancel out the 3's. That's 3 minus 12, that's negative 9. And that's 4x. And less than 9 plus 3, that's equal to 12. All right, and lastly, to get the x by itself, how about we divide both sides by 4? All right, so let's see. That cancels. And 12 over 4, 12 goes into 4 3 times evenly. That's just x. But 9 over 4 does not go evenly, so just leave it as a fraction. All right? Decimals might be required if you were ever required to apply this to some physical context or some other context. But well, in this case, at least, we will need to keep this in fractions. Right? We leave them in fractions. We leave them as fractions unless otherwise stated. Sana?
So we will not calculate like LCM for this?
Which one?
Like the first step we will...
Oh, yes. So, oh, yes, we need to write that down, the x such that, just copy and paste this inequality, negative 9/4 less than or equal to x less than 3. And using interval notation, it's a bracket for the negative 9/4, comma, 3, 4, parentheses. Right? And that's about it, actually. That's about it. Okay, so why are we doing these kinds of inequalities? Well, that's because later when we get to the trigonometric functions and when we define domains and ranges for these wave functions, well, it turns out that, well, just to give you the heads up of what it is about, well, we need, when it comes to writing the range of a shifted trigonometric function, we need to use this kind of inequalities based on the range of sine and cosine, which goes between -1 and 1. And it turns out that we can represent those using these kind of compound inequalities. Well, right now it's too early to talk about these domains and ranges. However, well, we're going to get back to this once we get to the subject matter later, right?